A block of mass 3 kilograms is inclined on a 26-degree rough plane. The coefficient of friction between the block and the plane is 0.2. If the block is initially travelling at 10 meters per second and comes to rest, find the distance travelled. Okay, so let the acceleration be a meters per second squared, which is what we need to find first. So setting up an IJ plane and drawing in this one here, so we can split this into its two components, this component here and this component here. Then resolving in the I direction, which is this way, so there's nothing going this way, so it's going to be minus F and then minus 3g sine 26 degrees. And that's going to be equal to the mass, which is 3, times the acceleration, which is what we need to find. Now we know that F, because it's friction, is equal to mu r. So F will be equal to minus, in this case, 0.2 r minus 3g sine 26 is equal to 3a. Now if we resolve in the j direction, this direction here, we have r going upwards, and then 3g cos 26 going downwards. That gives r is equal to 3g cos 26. If we call that equation 1 and call that equation 2, and what we're going to do is we're going to substitute equation 2 into equation 1 instead of the r here. So substituting 2 into 1, we're going to have minus 0.2 times 3g cos 26 minus 3g sine 26 is equal to 3a. Now there's a common factor of 3 here, so we're going to cancel out all the 3's, and we'll have the a will be equal to minus 0.2g cos 26 degrees minus g sine 26. We know that g is 9.8 meters per second squared, so on my calculator working this out, I'm going to get, doing all this on my calculator, get minus 0.57 meters per second squared, which means it is actually slowing down and will eventually come to rest. Now, if the initial speed was 10 meters per second, and we want the final speed to be 0 meters per second, and then a is minus 6.057, don't round off prematurely, and we now use v squared is equal to u squared plus 2ac, 2as, we're going to have that 0 squared is equal to 10 squared, the initial speed, plus 2 times the acceleration, which is minus 6.057 times s. Rearranging that, we're going to have that s will be equal to minus 100, minus 10 squared, divided by 2 times minus 6.057, which is going to give me 8.253 meters. So it's 8.25 meters. So eventually it will come to stop a further 8.25 meters along the slope.